We talk a lot about energy innovation. We are sitting in a developed country, but all this innovation also has to happen so that it allows for those innovations to spread not just to developed countries, but to developing countries as well. And we are going to hear from a number of speakers at the start and then open the floor for discussion as we've done before, where we invite your views for the session, which will get fed to the G7 ministerial. To start off, we have the Minister of Energy for Ukraine, Svitlana Grinchuk. She's going to speak to us through a video, and after that, we'll have Ukraine's ambassador giving us some prepared remarks.
Dear Dr. Birol, dear Fatih, distinguished colleagues, ladies and gentlemen, it is an honor to speak on you on behalf of Ukraine, a nation whose energy system stands on the front line of resilience and innovation. For 3 years, our infrastructure has faced relentless missile and drone attacks. Over 4,000 facilities damaged, including power plants, grids, or gas sites. In October alone, around 4 gigawatts of capacity was hit. Around 800 megawatts restored, while most remains offline. Despite constant danger, Ukrainian engineers continue repairs under fire. Let me highlight the key technologies driving our resilience and future recovery. First, technology as the foundation of energy security. In wartime, energy resilience is not just about resources, it is a technological challenge. Conventional infrastructure cannot withstand missile strikes or cyber attacks, which is why innovation has become the core of our recovery strategy. Ukraine is developing a roadmap for small modular reactors, SMRs, a strategic step towards a safe, modern and flexible nuclear future. Another example is Ukraine's largest battery energy storage system, built by DTEC with Fluence US, 200 megawatts of capacity, 400 megawatt hours of storage, enough to power 600,000 homes for 2 hours, built it in just 6 months. These projects reflect Ukraine's commitment to technological resilience, energy independence, and global partnership. Second, innovation for Ukraine's immediate resilience. We focus on smart and modular grids for repaired fault isolation and system recovery. Energy storage systems, both stationary and mobile, to stabilize the grid. Decentralized heat supply through biomass, mini plants, heat pumps, and small combined heat and power units. Digital monitoring systems for the real-time fault detection and control. These technologies are vital to ensure that hospitals, schools, and critical facilities continue operating even during blackouts or emergencies. Third, the long-term vision and recovery of Ukraine does not seek to simply rebuild what was destroyed. We aim to reshape our energy system around the principles of decentralization, resilience, digitalization, and decarbonization. Our long-term priorities include SMRs and large IP1000 reactors as a foundation for the clean, reliable base load power and European grid integration. Renewable and hybrid microgrids with storage to enhance energy autonomy. Digital energy systems, smart grids, and advanced data analytics. Support for domestic innovation, startups, R&D, and local production chains. Regulatory reform and EU alignment to create a transparent, investment-friendly energy market. Even in wartime, Ukraine is proving that a clean, resilient energy transition is possible and irreversible. Fourth, global partnerships for the future. No country can achieve energy transformation alone. We can on our partners to continue supporting Ukraine through joint innovation, financing, and policy cooperation. 3 priority areas: policy, frameworks for SMR, storage, and digital infrastructure with clean, resilient standards. finance, blended tools, public, donor, and private, to fund critical projects and local technology production. Cooperation, technology transfer, capacity building, and pilot projects in nuclear, storage, and decentralized system. Your support and solidarity help Ukraine not only survive, but build a secure, sustainable energy future where innovations serve both progress and peace. Dear colleagues, your support helps us not only survive, but move forward toward a more secure, sustainable, and united energy future. Together, we can ensure that innovation serves not only progress, but also peace. Thank you very much.
Next, we have Ambassador of Ukraine to Canada, Andrei Plahotniuk.
Thank you so much. Distinguished colleagues, ladies and gentlemen, I will begin by expressing our most sincere gratitude to the International Energy Agency and Natural Resources Canada for organizing, convening this Energy Innovation Forum 2025 and for inviting Ukraine to participate. It is vital that Russia's ongoing brutal war of aggression remains on the global energy agenda because it directly affects energy markets, innovation, development, and global security. We are also deeply grateful to Canada, our trusted friend and partner, and to all countries, international organizations, academic institutions, business community represented here by you for the unwavering political support, financial, technical assistance provided to Ukraine, especially in the energy sphere. As the minister just mentioned, since the start of the Russia full-scale invasion in 2022, more than half of Ukrainian generation capacity has been destroyed. And according to the last World Bank RDNA4 assessment, the estimates for rebuilding the energy sector will require approximately 68 billion United States dollars. This is not simply a reconstruction task. It's a transformation challenge. As we all see from the media coverage and from reports from Ukraine, Russia continues its deliberate attacks targeting power station, transmission line, gas facilities, and heating systems. These attacks are designed to freeze Ukrainian cities into submission and to destabilize regional energy security. As we approach another winter under constant missile and drone fire, Ukraine needs for international energy cooperation and innovation is more urgent than ever. Canada's leadership in this regard has been instrumental. Through the Ukraine Energy Support Fund, Canada has provided 60 million Canadian dollars for vital equipment, transformers, generators, gas system components, and repair materials that keep hospitals lit, water systems running, and communities alive. We hope to see this partnership continue and expand. The Honourable Minister Grinchuk has already outlined the importance of implementing innovative technologies to create a more stable, efficient, and flexible energy system in Ukraine, which must be more resilient in light of the consistent threat of Russian attacks. Ukraine's experience demonstrated this vividly. Despite the destruction, Ukrainian engineers have learned to keep the system running under unprecedented conditions, rapidly repairing damaged facilities, rerouting power flows, and integrating temporary generation sources to maintain supply. The country is increasingly focusing on decentralization and distributed energy systems, including microgrid and renewable pilot projects designed to enhance resilience. Ukraine is also working to expand smart metering, energy storage, as Minister mentioned, and digital monitoring as part of broader modernization of its power sector, steps that will strengthen both national security and future development. Ukraine is determined to rebuild its energy system as green, digital, and distributed with renewable storage, hydrogen, bioenergy, and small modular nuclear reactions, which once again were just mentioned and highlighted by Minister. To achieve this, we need certainly investment and risk insurance, apart from what was mentioned by Minister, to enable private capital to participate in reconstruction. Another area which is equally important for all Ukrainians is certainly human capital cooperation, training Ukrainian specialists in advanced energy technologies. In this regard, certainly Ukraine welcomes the deepening of cooperation with all G7 partners and not only with G7 partners, but all partners in the world. Canada's expertise in renewables, clean hydrogen, SMRs, and grid modernization is particularly valuable. Once again, dear friends, Ukraine is determined to demonstrate that even under the most difficult condition, innovation can and will prevail over destruction. Thank you all for attention and for standing with Ukraine in defending both energy security and the values that unite us.
Thank you for those remarks. Next, we have Madhavi Srinivasan, who's a professor at Nanyang Technology University.
Good evening, distinguished ladies and gentlemen. I'll just grab my slides, yeah. It's my great honor and pleasure to share some of the work that we are doing in Singapore on energy transition. So my talk is focused more on our approaches that we take to energy technology innovation, and mainly focusing on R&D. That's where I come from. That's Singapore, a picture of Singapore. And cities like Singapore make up only 2% of Earth's surface, but 50% of world population lives in cities. And there is a projection saying that by 2050, 70% of the world population is going to be residing in cities, and majority of the new cities are going to be in Asia and Africa. Cities like Singapore consume 75% of world energy and 80% of global CO2 emissions. So it is very important to take action in cities to reduce emission. Numbers are at least 80% by 2050, and that's something that we do in Singapore. Cities like Singapore have very different challenges from G7 countries. Our grand challenge, these are just some of the examples. Singapore, we are renewable disadvantaged. We don't have large areas to put solar farms, wind farms. We don't have much wind. We are land constrained, and this is true for cities and emerging economies. What do you do, and what are the solutions when you're land constraints? You don't have enough renewables. And on our part of the world, tropical cities, we have problem of cooling. It's not heating, but we need cooling. And there are studies which says that when you want to cool a building in a very hot climate, you actually end up spending 3 to 4 times more energy than in other places. What are the solutions? And there are what is called as an urban heat island effect, where urban cities, because of lack of greeneries, are much more hotter than the other places, like suburbs. Grid infrastructure need to be developed in emerging economies, and all of these needs to be done ideally with energy cost, reduced better security, reliability. And for all of these, addressing these challenges, it is very important that innovations are there. And I want to add a caveat to say that it is not one size fits all. Energy innovations need to be tailored to different countries in different regions. Even in the Southeast Asian context, different countries have different challenges which needs to be addressed by different innovations. What do I mean by that? So if you broadly look at energy transition innovations, there are 3 things that we work on in my institute at the university. We look at energy supply, energy grid, and energy demand. And according to IEA report, 35% of many technologies that are very critical for our net zero CO2 emissions are not even commercially demonstrated yet. So there is a need to accelerate these. So what we work on, this is not an exhaustive list, but we work on different R&D technologies in the energy supply side, more importantly, the energy grid, which is very overlooked. So when you talk about integrating these energies and in a grid level, there are multiple challenges from smart grids to virtual power plants. So we have a lot of R&D going on. And on the energy demand, we also look at how do we efficiently manage these energy demand coming from different applications. What we try to do is we bridge the gap. There's a lot of basic research, TRL level 1 to 3, that's happening in the universities, not only in Singapore. We collaborate with Singapore, ASEAN University, Asia, and also G7 country universities to look at potentially trying to take this TRL level 1 to 3 technologies to TRL level 4 to 6 in terms of demonstration. and then start working with industries, companies, agencies to take it to commercialization. This sort of a bridging we have seen is very, very important. Otherwise, a lot of innovation stays in the lab. We also work with a lot of startups and companies who come to us to do some sort of a demonstration and de-risking of some of their technologies. So that's where we operate. One of the models we have done, and we have been doing this for the last 15 years, is we call this a triple helix model, where we closely work with a public agency and industry. The universities, of course, contribute researchers, manpower, talent, students. Public agencies provides capital funding, strategic support, policies, and also an economic context, which is very critical for energy innovations. Working closely with industry helps to accelerate the commercialization of a lot of technologies, or quickly get a feedback which can go back to R&D and solve some of the critical problems. So my key message here for energy technology innovations R&D is definitely there is a need for more funding to accelerate energy R&D, but not just in isolation. There has to be energy R&D funding to bridge this TRL level 1, 3, all the way up to 6 and 7, such that we can accelerate many of these innovations. One of the things that we have seen that works is supporting funding and access to living labs and test beds. These living labs and test beds provide a platform to showcase some of the new innovations that are there in the lab. And when you showcase them in a living lab test beds, then it is easier for companies to adopt before even going to the startup company or startup phase. Lastly, what we see is many of our innovations, Singapore is a small country, but we collaborate extensively internationally, which really helps us in accelerating our own R&D and also looking at some of our innovations being deployed in some other countries. This is my last slide, where I wanted to show some examples of what we mean by R&D test bed project. The first one is an island off Singapore. It's called Kusu Island. This island is not grid connected. So what we have actually demonstrated is a small microgrid, about 230 megawatts of solar with lead acid batteries, not yet lithium ion batteries. We also set up a reverse osmosis seawater turning to pure water kind of a plant. And this was done by funding from our local government agency and also industry support. We have solar panels the size of 2 basketballs, and all of this we have tried to take the marine ecosystem into account, such that there are about 150 people who visit this. It's like a Buddhist temple there. And such microgrid projects have sort of become examples for the Southeast Asian region to see whether that can be modeled in other places in Asia. The second project I want to highlight is lithium-ion battery recycling. This is my personal project. So we've been working on recycling lithium-ion batteries for 5 years, and we had some new technologies, environmentally friendly technologies, where we used bio-waste to actually treat battery waste. So this is a totally environmentally friendly solution that we showed in the lab. With industry funding, we were able to set up a pilot plant that you're looking, so where we are able to treat 1 ton of black mass. We are able to extract more than 95% of critical elements from the battery. And we do that by 20% cost reduction and also 20 to 25% energy reduction. The other examples, I won't go into detail. What you see on the top, we try to use our university as a living lab. There are over 30 companies whom the university has partnered with government funding, where we have test-bedded their energy innovation solutions on NTU. And what this has led is, from 2011 to 2020, we were able to decrease the overall energy consumption that's happening in NTU by 30%. So such projects sort of tells public, and also is a reiteration of the energy innovations that companies are doing. The bottom one is on cool paint. Cooling is a big challenge in Singapore and also in the tropical places. So this is a cool paint technologies that was developed by one of the professors at the universities. Now we have scaled it up, and we are actually coating this technology in multiple housing estates and also Singapore Zoo and Singapore Wildlife to see how much is the energy reduction. The last is an example of international partnership. We are partnering with a company called as Aquatic in the US, where they are going to set up a plant in Singapore for tapping CO2 removal using oceans. So these were just some of the examples of my use case to say that for R&D innovations, more funding for test beds, living labs, and also more international cooperation partnership is necessary. With that, I would like to thank IEA and Canada for giving me this opportunity to share some of the research. I'm happy to have a discussion and questions later during the break. Thank you.
Thank you very much. Next, we have Diana Maranga of Octavia Carbon.
Distinguished guests, ladies and gentlemen, good evening. I hope you're all well. First and foremost, thank you for all the insightful conversations and speeches and talks and breakout rooms before mine. It's really inspiring to see all participants across the ecosystem, from investors, policymakers, government officials, project developers, academia, towards the fight of the biggest crisis of our time. I was invited and asked to bring a different but relatively similar perspective from across the globe, from exactly 12,300 kilometers away, and a country that is certainly not a member of the G7. My name is Diana Maranga, and I'm the head of commercialization of Octavia Carbon, Africa's first direct air capture company based in Nairobi, Kenya. So for us, direct air capture is not just a climate solution, it's a development story. It's about proving that high climate tech innovation can originate, operate, and flourish in the middle to low income countries, powered by local talent, abundant renewable energy, and a shared determination to build a cleaner and fairer future. So Kenya offers unique advantages for this, for direct air capture specifically. Our grid is already over 90% renewable, thanks to geothermal and solar energy. We have a young, highly skilled engineering workforce and a low-cost manufacturing base, and a policy environment that is increasingly growing supportive of climate innovation and climate technologies in particular. But of course, it's not easy. Developing a direct air capture technology in Nairobi is definitely not similar as doing it in Canada or the US. We face the classic challenges of developing economies, most prominently limited access to capital and funding, complex import logistics for high-tech components, and infrastructure constraints delaying critical R&D decisions. But what's often overlooked is that these constraints breed innovation. They've pushed us to design simpler, modular, cost-efficient systems that rely on local materials and local skills, and they've forced us to think creatively about partnerships, financing, and operations, and ultimately to build a technology ecosystem that's both resilient and self-reliant. So in a way, Kenya has become a proving ground for how carbon removal can be made more affordable, inclusive, and globally relevant, and precisely the kind of cost reduction pathway that the IEA highlights as essential for the next generation of CDR technologies. So what's our progress so far? Earlier this year, and just throughout the year, we've achieved a couple of significant milestones that we're incredibly proud of. We have achieved 5,000 operational hours from our pilot direct air capture and storage project, Project Hummingbird, which is bound to ultimately capture and permanently store 10,000 tons of CO2 across its 10-year lifetime. Owing to this, we have also completed Africa's first CO2 custody transfer, delivering air-captured CO2 to our geological storage partner, a mineralization company co-located with our project in Gilgil in Kenya. So this proves that we have fully de-risked the direct air capture process, from getting CO2 molecules from the air, processing them, and transferring them to our partner's custody. So this marked the first fully integrated capture to storage chain in the continent. In the coming weeks, and by mid-2026, we expect to deliver first verified carbon removal credits. So to put that in perspective, this places Kenya and Octavia Carbon amongst a handful of direct air capture companies worldwide that have achieved this stage of maturity. So this is just a reminder that exciting things are happening and in places that people do not expect. So what have we learned in this journey, in this 3-year journey, that might resonate a bit more broadly? First, innovation in emerging economies requires inclusion, but not limitation. Copy-pasting models from the global north of Canada does not work, and success depends on designing around local realities, resources, and institutions. Second, access is everything. Access to finance, access to markets, and access to recognition. So blended finance and early procurement commitments, like those pioneered by certain governments and companies such as Microsoft, can give innovators the confidence to build and scale. And third, partnerships matter. Our collaboration with international standard bodies such as Puro.Earth has given global credibility to our work while ensuring transparency and quality, and commercial partners such as Carbon Future, Climate Co, TerraSet matter in validation and credibility. So these lessons are transferable, I hope, and they can help guide how policy, finance, and cooperation can make innovation ecosystem in developing economies truly thrive. So as I close, so at Octavia, our journey started with a small team in an apartment and a big idea. That the fight against climate change should be built everywhere and by everyone. Because innovation is not a privilege of geography, it's a reflection of human will, political will, creativity and cooperation, and most importantly, at least from Octavia's perspective, resilience in navigating uncharted waters. We look at the progress that Canada has made with deep admiration, especially with the radical and full embrace of CDR technologies. The conversations and announcements today have been truly, truly inspiring. So, hongera sana, deep congratulations. And as I wrap up, I hear there's a lot of talk today about a team called the Blue Jays. I have to admit, I've never heard about them until today. Now, in Kenya, we might not have a world-famous baseball team, but we're pretty good at something else, and that's track and long-distance running. And if race to net zero and race to cost reduction is a marathon, well, let's just say nobody runs as fast as Kenyans.
Thank you. Next, we have Philip Johnson at Six Nations of the Grand River Development Corporation.
Good afternoon to everyone. Thanks so much to the IEA and the Government of Canada for inviting an Indigenous voice to this forum here today. My name is Phil Johnson. I'd also like to say go Jays. It's an honor to be here among international professionals and learn about the energy innovation that's on the horizon. Okay, I'm proud to represent my organization, which is the Six Nations of the Grand River Development Corporation. I'm from Six Nations. I'm from Oneida Nation. I was born and raised on Six Nations. Six Nations of the Grand River Development Corporation was founded in 2015 to create economic self-sufficiency for the Six Nations of the Grand River. Six Nations is the largest First Nations in Canada by population, with approximately 29,000 registered members, and the second largest First Nations by size. We are a 90-minute drive, that's without traffic, southwest of here in Toronto, and about a 20-minute drive southwest of Hamilton. Our treaty land is comprised of 950,000 acres, 6 miles on either side of the Grand River, but today we occupy a First Nations and our land is approximately 47,000 acres. What I'm here to talk about is an innovative idea, which is Indigenous participation in a large-scale battery storage project. This battery storage project started with an idea. This idea was between an organization called Interstore Inc. in our organization, Six Nations of the Grand River Development Corporation. Six Nations of the Grand River Development Corporation has ownership equity in a number of wind and solar assets as renewables align with our core values of protecting the environment. Our energy portfolio currently stands at 154 wind turbines, that's shared equity, and then 646,000 solar panels. We also have ownership equity in the Niagara Reinforcement Transmission Line, which is a transmission system, so both generation and transmission. In order to unlock the full potential of both current and future renewable energy projects, the idea of battery storage was formulated, again with our founding partner, Enerstor. This was between our CEO, Matt Jameson, and Enerstor's CEO, Annette. Renewables generate energy intermittently, so when the wind is blowing or the sun is shining. Having storage reduces the impact of energy curtailment, which primarily affects the wind assets. And then sometimes renewables generate when the grid doesn't necessarily need it. So in order to achieve a large-scale project like this, we have our partners listed there. So Six Nations of the Grand River Development Corporation, Enerstor, Northland Power is the current operator, and they hold the majority interest into the project. AECON helped build it. Along with AECON is A6N, which is a majority-owned organization by Six Nations. We own 51% of that, which is a partnership between us and AECON. Another First Nations, Mississaugas of the Credit. The Government of Canada provided funding for this project because without funding, without the capital, this project would not have happened. And then the Province of Ontario, through implementing policies with the IESO to ensure that this project was completed. So the innovative idea resulted in the solution, which is the Oneida Battery Storage Project. This is a large-scale battery storage project that's located in Haldimand. I want to make sure that we mention Haldimand as well. You need a willing host to host these large-scale projects. It's in Jarvis, Ontario, right next to the Jarvis Transfer Station. Just some stats, it's a 250 megawatt, 1,000 megawatt hours of storage system capable of powering a city the size of Oshawa, or 400,000 people, for 1 hour. It went into operation May of 2025. It has over 278 lithium-ion battery packs. It's currently the largest battery storage facility in Canada and the 4th largest in the world. But there are other battery storage projects in the queue right now. The only way that the finances worked for a project like this was an agreement between us and the IESO, so that resulted in a 20-year capacity agreement. It was constructed for $700 million, which was about $100 million under budget. It was also ahead of schedule, and this would not have been possible without Indigenous participation. So some benefits for this. So the template of this type of project exists now for future energy projects. With Indigenous participation, one of the big benefits will be that it will reduce the costs for ratepayers in the province of Ontario. It's also expected to reduce emissions by 1.2 to 4.1 million tons, depending on how much it's used, or approximately 40,000 cars off the road. We're really happy about the fact that it's created jobs. About 180 construction jobs were created as a result of this project. But really important to us is the fact that it created capacity for our organization, A6N, so that they're now part of other large-scale battery storage projects and helping to build them. So the innovative idea mirrored with our innovative funding model. So our organization supports Six Nations of the Grand River, and our surplus revenue that we generate, 50% of it goes directly back to our community. So 40% goes to our band council, and then another 10% goes to community initiatives and grassroots organizations. So we're really proud of that funding model. It's amazing to see what happens when innovation meets collaboration. Not only will our community see improvements to infrastructure, but all ratepayers and the environment will benefit. Thank you very much.
Thank you. And now I'd like to invite people on the table, but also people sitting in the audience to think about contributions they'd like to make. I'll just start with a few questions I have for the speakers. Diana, could you tell us a little more about the demand for carbon removal and how, you talked about how Microsoft having these deals with large companies has been very helpful, but it really has been Microsoft as the lone buyer in a way, because the vast majority of the market has been created by Microsoft. But how are you seeing demand for the credits that Octavia is looking to produce?
So there's no denying that Microsoft is a huge supporter of CDR across all technologies, DAC, biochar, etc. Microsoft haven't purchased from us yet, hopefully. There's a lady from Microsoft around. For us, more specifically, I can speak on our clientele, and perhaps this is replicable for a couple of direct air capture companies here. So most of our clientele our buyers are in the global north, so US, EU, and it's mostly folks that you'd expect in the tech and finance institutions who just perhaps have the financial muscle to invest catalytically in pre-purchases in direct air capture, specifically a company that's just pioneering it in the global south in Kenya. But also most of our buyers are intermediaries or brokers, etc. So folks who have the technical know-how to conduct intense due diligences on our projects, technology, funding processes, just as Microsoft does, and we talked about that in the break room, and then they go ahead and sell it to an end buyer. Sometimes we know who the end buyer is, sometimes we don't. But for example, one of the deals that we made earlier this year, and I've mentioned this commercial partner, Carbon Future, was to SIX, which is the Swiss stock exchange. So that's just how our clientele is. So the demand is there, at least for direct air capture credits. And just to speak to Octavia specifically, I mentioned our pilot project, Project Hummingbird, will have the capacity to capture and permanently store 10,000 tons of CO2 across its 10-year lifetime. That's in totality. So we've been able to sell 42% of that so far, and hopefully will sell out the rest by the second half of next year. But yeah, that's my answer for that.
Thank you. We have a contribution from that side.
Thanks very much, and thanks to IEA and Natural Resources Canada for having us. It's James Jenkins. I'm the Executive Director of Indigenous Clean Energy. Just want to briefly expand on how significant Indigenous economic participation in Clean Energy Canada has been, and that it's continuing to grow. So I think Six Nations of the Grand River is arguably the leader of the pack, but there are Indigenous-owned or co-owned projects in every region of Canada now. We're tracking over 600, and many of those are 50 megawatts or more. Equity share is significant, often 50% or more. It's a major share of Canada's generating infrastructure. So one point I want to make, Canada has something unique called constitutional spheres of jurisdiction, which means energy is actually provincial responsibility, but the federal government can influence that with grants. And that's really contributed to some of the success we've seen. Indigenous communities have leveraged those grants over the last few years and have been able to participate in these partnerships and move projects forward in remote locations, diesel-reliant locations. And it can feel frustrating from our perspective. I do want to make that clear. Some of these projects take a long time to start to see some success. But as we've participated more in international work and talked to Indigenous brothers and sisters in the other parts of the globe, we see there's a lot we can share in terms of what a good project a good partnership and true Indigenous ownership looks like. Last year, we met with 88 delegates from around the world, Indigenous delegates, and completed a joint declaration of principles for Indigenous ownership of clean energy projects. And there's a lot of work to be done in that area. And I think the 2 points I want to make, one is the federal intervention in this area really has made a difference when it comes to Canada, and it's opened up economic participation for many Indigenous communities that otherwise might have limited options. And there's a real synergy of values there. So that has worked. The other piece is there's a lot more we could be doing internationally to facilitate the kind of conversations that would lead to innovation. And it's not limited to just clean energy projects. It's smart grids, microgrids. How do we make this work in remote locations? How do we expand that to some of the more complex needs? And I think what could be driving that, or will start to drive that more, is Indigenous communities want to know that some of the minerals feeding into their projects, some of the value chain is done sustainably and with the principles of true Indigenous participation in these kinds of projects. So that, there's a real need to start having those conversations, facilitate those conversations, and it is, in my view, an untapped area of innovation right now, given the Indigenous participation that currently exists in the sector. So thanks.
Thank you. We have two interventions there, so do you want to go first and then David next?
Good afternoon, I'm Michelle Patron with Microsoft, and first of all, I want to thank you all for your leadership and your inspiration. When I was listening to each of your presentations and solutions, it just struck me at how important local innovation and local solutions are, if it is with Ukraine and the need, and how you are developing a strategy about decentralization and resilience, if it is about Singapore and the way that you are looking at your island solutions and focused on obviously the energy efficiency and the heat issues. I'm blown away on the innovation on DAC and CDR, so I look forward to hearing more about this project and the project with local nations and the role and the stake that the communities have in the actual projects. Two comments and one question. On the comment, I mean, the other thing that is so inspirational is when Microsoft set its target in 2020 to be carbon negative, there was no carbon removal market. We didn't even know really what carbon removal was. We said, okay, let's put a request for proposals out there. Let's set some criteria working with academics and experts and see what comes in. And then seeing where things have gone from 5 years ago to today, including the announcement we made with Accra, is really exciting and catalytic of how you can both send that demand signal and the catalytic capital to be able to let local communities develop their own solutions. So I really look forward to more of everyone in the room joining us on this journey and hearing more about the project. The second point is just the real importance of community involvement in projects and community stakes in projects. One of the things that we've been focused on in the United States and India and hopefully in other places is dedicating a portion of our energy procurement to community-based projects. So in the United States, we've dedicated 500 megawatts of our demand to building community projects in which the communities have stakes in the projects. They are able to, they get a share of the revenue and are able to reinvest them. And they've been very small scale in some cases, 6 megawatts, and in some cases 100 megawatts, but just that's really been, it's shown its value. And when I was listening to the last speaker and what you were talking about, I just thought about how important that is. I want to shift from energy to AI because when I think about the development of local solutions and the availability, I think that we have an opportunity to make sure that AI is widely available We know that you need energy. We know you need interconnections, and you need skills. But we have as a world and as a community, have an opportunity to make sure that it's widely available around the world and to all communities. So I just wonder, based on your experience in the energy sector, are there any key principles or lessons learned that we could be deploying as we think about the build out of AI infrastructure and the usage of AI to ensure that it is widely available?
I just have a comment. I'm not sure they're going to answer your question, but AI has become a very large part of the energy transition. And I didn't have enough time to share examples. So what I shared was a lot of living lab test beds, which are infrastructure. AI is the layer that's going to go on top of it to really talk about smart grids. When you say smart grids, AI is a very integral part. We are realizing that. And AI is a very integral part in terms of energy efficiency. We have a project on what we call as virtual power plants. These are just aggregation of different energy assets which are not in the same region. It can also be in different countries. But can we have a virtual power plant? And one of the key components that is going to make it happen is the AI layer that's going to sit on top of it. The other experience we have had where AI is very critical is looking at constructing digital batteries, looking at a digital building infrastructure. That means you don't have a physical building or a physical battery or a physical grid, but it's a digital layer. And to do that, I don't think we are yet utilizing AI's potential to the maximum. We have just started doing that. We see a lot more potential that AI can bring in. Yeah. Thank you.
David.
Thank you, David Hart from the Council on Foreign Relations in Washington. I also have a question for Professor Srinivasan, which is, how does Singapore think about the trade-off between autonomy and interdependence? You alluded to land constraints and other constraints, but obviously those would be alleviated through interconnection. But that comes with a cost. So I'm sure Singapore has been thinking about this question for a long time. I'm just curious what your thoughts are on it, given the disruption that my country and others are creating in the world.
Thank you. So I think it's a problem that we are facing. We don't have a solution out of it, but one of the things that has been very clear is that we don't have enough space to put more renewables. I think Singapore has gone to evaluate on solar, wind, and other possible approaches. Given our land constraint, we are almost maxing out on solar. That's our only renewable that's available. We have a bit of a geothermal. So where we are going heavily on in the last 2 years is energy imports from our regional partners who have a lot more renewables, from hydro to wind to solar. So I think where Singapore is going towards is energy imports and an ASEAN grid. There has been some interest from the early part of this year on small modular reactors, but there's a lot of discussions about whether that would be in Singapore or that would be somewhere in the region where Singapore would have access. So I don't have an answer to that, but these are the potential pathways that we are thinking. Thank you.
Thank you. If there are no more interventions, then I will like to go to the final session of the day. If there are any last hands people want to raise. Is there one there? Oh, a couple of there. I'll take those two before the next session.
Good afternoon, and thank you for the opportunity to speak. My name is John Bucknell, and if you heard my comments in the earlier session, I'm the CEO and founder of Vertisolis. We're an American, Canadian, British energy business. I just want to make some comments around the scale of energy globally. Today, we're about $14 trillion of global expenditure on energy per annum. And of that, we in the West consume about 9 kilowatts individually. The global average is about 1.8. There's about 750 million people who are actually operating at zero. And the feedback is that demand without a cost constraint is effectively infinite. There's a lot more energy interest out there than that can be consumed. And the AI demand on top of that is even higher. It's between 30 and 50% more. And the question becomes, Where does this come from? We're at currently about 27,000 terawatt hours annually globally. We're projected to grow to about 36,000 terawatt hours by 2030. In the US alone, AI demand is projected to add another 130 gigawatts of additional generation required by 2030. And the biggest question is where all will this come from? That's about almost 4,000 SMRs from the GE or Westinghouse size, 2,500 of the Rolls-Royce size, or almost 16,000 of the Oklo or NuScale sizes, and only one of those has a licensed design. If you were to stand in the conventional technology, that's about 4,400 combined cycle natural gas power plants. And if you want to stay in the renewable space, it's between 12,000 and 24,000 new solar farms, plus an additional 11,000 battery energy storage projects that are 12x what are typical today. So just to put it in context, Vertus Solis is a clean, firm, low-cost energy provider. We put solar panels in space where they're productive all the time. Land use is quite small. It's comparable to nuclear because you're able to generate all the time in a very small land use. And to that end, it's scalable to bring prosperity to everyone. That's about the end of my comments. I will say that we're about 2 weeks out from making a substantive announcement with one of our customers. And I thanks to the IEA for inviting us as a local space solar power company. Thank you.
Thank you.
Thank you for an invitation, especially to National Resources Canada. My name is Zenon Potishny. I am president of Canada-Ukraine Chamber of Commerce, and it's a non-profit organization involved in increasing trade and investment between the two countries, Canada and Ukraine. And I just wanted to underline again, as you heard from Minister of Energy of Ukraine and Ambassador of Ukraine in Canada, how important everybody's support for Ukraine, especially right now during the war. One of the things that I would like to mention is that our organization has been working in Ukraine for over 30 years. We're still working in Ukraine. We didn't shut down our office in Kyiv during the war, and there's a lot of experience. We can help you if you know or you have some equipment that you want to donate to Ukraine. Please speak to us. We can help you through the logistics, through everything, because we do this every day now. That's part of our sort of job right now to help Ukraine. If you have maybe some ideas what you can sell to Ukraine, some commercial projects, we can help you with maybe closing these deals, helping you with making sure that the deal is done. We also have a whole bunch of investment projects on our table that we can present to you. Ukrainians are very smart people, very, very innovative, and you can do a lot of things jointly with them. You'll be surprised what can be done. All I want to say is that we are here in Toronto. We have an office in Toronto and in Kyiv, and we're always ready to help. Our website is cucc.ca. And just a little maybe marketing spiel at the end. We have our Rebuild Ukraine conference early December 2nd in Toronto in the hotel here, and please come to that. We get at least 450 members coming from Ukraine, from government and from private sector, and you can hear again a lot of projects, a lot of things you can find out and learn. And thank you very much again for supporting Ukraine.
Thank you. Let us just thank all the speakers for this session before we move on to the next session.